Hi everyone, welcome to our SSW TV studio at NDC Sydney 2022, and I have Chris.
Hi.
So you are?
So I'm a software engineer at Microsoft, and I work on the Roslyn compiler in C#. And for the last couple of years, I've been really focused on the source generators effort.
Nice. Yeah, I think source generators are becoming more and more popular in .NET right now. It's like the amount of work that it saves us, not just analyzing the code, but now even generating it, especially
absolutely.
in .NET 7. It's really, really cool. Do you want to have a bit of a talk about that?
Yeah, so I think the two main things that we see generators being used for, there's two really interesting use cases, right? One is this idea of moving things which were at runtime into compile time. So, if you had the regex generator that's built into .NET 7, for instance, is a really interesting idea of this. That where before, because just the way the code was, your app would run and then it would have to compile the regex at runtime and then use it. It can now use generators, move it to compile time. So we can actually just make things more performant by just pushing it into compile time where we couldn't before. And those are the sort of invisible generators, right? Things just get faster, or like JSON serialization, right? We can push that into compilation. And so that just makes the developer's life better just by it being there. And then I think the second case is the really obvious common case is removing boilerplate, right? And so, we see there's the obvious things like I notify property changed in WPF, right? There's just a lot of boilerplate you have to write, and there's for good reason. But there's also other things. There's things like if you want to use command patterns, you have to have a command and then you have to have a method. And this is a lot of things you have to do. And there's we're seeing generators now that just take a lot of that thing out because it's easy to generate it. It's obvious what it's going to do. And it's just boilerplate. And so I think that's where we're really seeing a lot of people enjoying using generators where you can just say, no, I want this thing to be I notify property changed, go generate it for me. And so I think they're the two really big use cases we're seeing now of generators as their usage is being picked up.
Yeah, and the cool things that I'm seeing with code generators is with regex, for instance, I usually try to compete to write better code than the regex because I trust my code more than regex for a couple of reasons. Security was one of them.
Yeah.
But the latest one in .NET 7, I was just yeah, it's a simple regex. I'll just write my own code. And I said, why is the regex twice as fast? Okay, I was trying really, really hard, and I wasn't able to get it fast.
Right. No, it's a very mature engine as well. And the great thing as well, of course, if you're in Visual Studio, you can actually go and see that code, right? You can go in, you can open the dependencies, look in the analyzers. You can actually see the code that's being generated. So you can actually, you can inspect it from security and make sure it's doing the right thing. But also, it's a sort of fascinating way of actually seeing some of the inner workings of things like regex. So.
Yeah, we're coming from a point where it's no, try not to use regex to, just make sure that it's safe, maybe timeout, and it'll be good. Yeah. And what you also mentioned, the commands and stuff like that, we can then do good practices behind it, right?
Yes, absolutely. And it's because it's being generated, you don't have to think about it, right? You can just say, you can describe your intent rather than actually having to write code to do that. And you just say, I would like some code that does this, right? I would like it to be a command pattern and I want it to make sure that it handles parameters in a certain way, whatever. And then the generator can do that for you. And you can be assured that that generator is writing good code for you. So I think there's definitely a use case for it there.
Yeah. And one thing that I see a couple of people wondering is, we have quite a few things, we have the analyzers in .NET, and we have analyzers in NuGet. Then you can write your own. Then you have IntelliCode, IntelliSense, and GitHub Copilot. Can you just give a little bit of summary how everything comes together?
Yeah, and so it's kind of you can think about it as being, a sort of pipeline of from source code to assembly and the DLL. And things like Copilot and IntelliCode work kind of fairly close to your code. Mm-hmm. And what they're really doing, they're analyzing it and generating code for you. But when you accept those changes, they're physically changing the source code on the disk, right? It's just, rather than you physically typing it, it puts stuff into your file for you. And so they're the very early stage generation tools. And then we have source generators, where they actually run inside the compiler. And so they don't change your code, they generate new code, but they're not physically changing anything on the disk. Whereas like IntelliCode and Copilot are physically changing stuff for you. And I think that's kind of the real difference between those two things. The generators are happening in memory. And then we go down to analyzers, and analyzers are running on the output of all of that, right? So you've got the IntelliCode changes the file, source generator generates a new file, and you've got more code, and then the analyzers can then look at all of that code together and see a complete picture of the universe, which is what they then can give you information and tell you how you should change your code to make it more efficient or whatever.
Nice. And basically the GitHub Copilot and IntelliCode, the kind of AI things, so they basically look more like in raw text files where the analyzers...
right. They've just been, so those things, they've just been trained on a lot of source code. And so they just sort of implicitly, they don't really have a semantic understanding of the code.
Yeah.
They can just look and they can see patterns, and code is very highly patterned, so it works very well. Whereas analyzers and source generators, you have full access to the compiler internals, right? It has a deep understanding of the language. So rather than just knowing it because it's text, you can actually understand that, hey, this X here in this file is actually this X over here in a different file, because we have that semantic understanding. And so that's where they can do a much richer, deeper analysis of C#. Of course, the thing is that it only works for C# because it's not, we don't have the model for another language. So, so yeah, that's kind of the difference between them.
Yeah, and now there's the exciting thing of incremental builds. So, incremental source generation.
Yeah. Yeah. So, I mean, we shipped source generators a few years ago now, and they worked quite well, but they have some perf issues in the IDE because they basically the compiler doesn't know about what information you're using, right? So I said that, like, we've got that semantic information. The compiler just kind of gives you everything and you generate some code. But it means in the IDE, if I type in a file, we have to go and rerun every generator because we don't know if they're going to change or not. And obviously, if you have like very complicated generators, that can get slow and you can run into problems. So the incremental generators are a new kind of source generator, which rather than actually writing the code yourself, you basically say to the compiler, these are the things I want you to do for me. And it builds up this kind of model of execution rather than code itself. And then what the great thing is, that means that when I go type in that file, the compiler now knows, it has a deep understanding of whether that change impacts the code you generated or not. And so it means that for a lot of changes, it can just say, oh, I don't need to run you because nothing's changed. But then maybe if I go type in an additional file, it goes, oh no, that would result in a change, so I will rerun that. But we only rerun the bit that actually has to. So now it's very, very fast. And so a lot of that analysis you do, it just does it once. Because, if you're in a code base, you're probably not changing all of your files all of the time, right? You're working on one particular area. And so all of that other stuff you generated is still valid. And so we just don't run it anymore. And so that was kind of the real big difference. And that's why we get a much, much better performance out of these things, because the IDE can just intelligently choose which bits of you to run, but still make sure the code is correct that gets generated.
Yeah, and if I remember correctly, this is coming with 17.4?
No, so we shipped incremental generators in 17.0, actually. They were,
okay.
Yeah, so they've been out a few releases now. It was in 17.3, we added some new APIs. So we had previously, when you wanted to look at like syntax and things, it was quite manual. You had to go and understand the semantic model from ROS and understand syntax. And it turns out that like probably 90% of the thing people are doing is they just want to get code that has an attribute on it, right? Like it's very common that you use an attribute to trigger a generation point. And so that code just needs to go, give me all the places that have this attribute. And so one of the features we shipped in 17.3 was an API to do that. So now rather than having to manually go through and understand, you can just more express your intent of like, hey, I'm interested in code that has this attribute on, and we will give it to you. And obviously the compiler can do that like very fast, very efficiently, and correctly as well. It's not actually an entirely trivial problem to do. And so you can do it yourself, but it's hard to get right. And so now instead we're just like, yeah, here's this API that you can use to do this, and it will give it right. And so we pretty much all of the generators in the Netcore runtime actually do that. They're all attribute based. And so we switched all of those over, and we saw, even with, very well written code, we still saw perf improvements there because it was now using this even faster method. And the code's just much simpler, right? We don't have all of these copies of let's go understand attributes and Roslyn. It's just like, no, just give me the code and I will do what I want with it. So it's, yeah.
Yeah, it's what they say. The best performance you can get is when you don't need to run anything.
Yes, exactly.
Yeah, so essentially, if you have Visual Studio 2022 already, you have everything in. There might be a little bit of a caveat that you need to use the new APIs, right? So
yes,
might not get.
Yeah, so I mean, there is always a lag because obviously when we ship new Roslyn versions, you need the corresponding new Visual Studio version as well. And so, there's usually a few releases for it to come through so that it can work. Because obviously if you use a 17.3 generator in Visual Studio 17.2 and you're using that new API, it's not there, it's not going to work. But yeah, I mean, within a few months, hopefully, like it's always that sort of sliding window. And so hopefully we'll get to that point where, everyone can just use those new APIs.
Yeah, so basically that's already a good reason. So I know a couple of people who use 2019, and that would be probably a good reason to get to
incremental generators. So incremental generators are not supported in 2019. So you need Visual Studio 2022 to run incremental generators. It was in Roslyn 4.0, which is what shipped in 17.0.
Yeah, and back then we have actually a pretty interesting conversation of what could be the future of source generators and maybe
and I feel like we've the last year or so we've really been focused on bringing incremental generators up to par with where source generators were, and we're now there. I mean, they're well tested, they're running, they work very well. So we're now just trying to sort of think about the future of what that looks like. There's definitely more of that, like this new API, that more declaring your intent, right? Saying actually these higher level ideas of like, hey, what if I could say, give me all the partial methods in this thing, rather than having to write it yourself. And so there's some areas there we're interested in exploring about just making it, easier to write the generators, easier to make them correct and fast, and just, giving you these building blocks that you can put things together rather than having to do everything yourself. There's also some ideas we have around like outputs. So today, when we call them source generators, they just produce source code, right? But absolutely, there's lots of use cases where you might want to produce other items. You might want to put other things on disk. And a good example of this is like for things like WASM. If you want to do interop with JS, you need to go write that JS code to actually do it. But you could imagine a source generator where you just tag a class and say, make this available from JS. And it does all the WASM generation, and then it would then produce a JS file as well on disk. And so that's what we call sort of artifact generation. And so that's probably one of the other things we're quite interested in pursuing and looking at to go. Not necessarily tomorrow, but I think we have a pretty good idea of what that looks like and how to do it. And I think we have enough use cases that we definitely want to go down that path.
Yeah, that's actually something I didn't consider, that with C# code and incremental source generation, we would also generate JavaScript and potentially other languages. That's very interesting to think about.
Yeah, absolutely. And there's a lot of use cases there for those kind of things. And there's lots of really interesting problems you can solve when you're allowed to actually start doing more than just generating source.
Yeah, and us as consultants being able to write simple code for code generation would be very helpful.
Yes.
Because we can basically get everyone into pit of success.
Yes, exactly.
Rather than write tons of documentation on how you're supposed to use things.
Yes, absolutely. You just say what you want and it generates the code for you. So.
Okay, all right. Thank you for all the very, very good information. And we're here at SSW TV studio signing off from JK, and have a nice, good day.